Okay, so today is a big day. Of course, next week is a break. Okay, so we are trying to cover as much as possible. So today we come back to the class 2 exercise, but before do that, I want to recap so at least we can able to check what we done. Okay, so mathematical model last session we started, and basically we have three systems. We already know about it, like mechanical, translation, rotation, fluid, and electrical. Okay, so then we have a transfer function and block diagram based on topic 2. So transfer function is very simple as to relation between output versus input. So end of the expression, we are trying to make it output versus input. So the calculation or the problem, what they say, what is input, what is output, we try to find the expression based on the relation. Okay, that we call as a transfer function. And we are preparing block diagram, and that is a generic block diagram. It can be a multiple gain or multiple feedback based on the question or based on the components. So the most common, of course, you can say your summing point. So your input versus your output. Okay, so there's two extreme. One is your input to your left side and sorry, right side, and your output on the left side. Two extreme corners, we have input and output. So if you take a summing point or take up the point from here, take up point, we will get as a feedback, then it is summation point. So let's say if your temperature is 25 degree, so that is your input 25 degree, setting as 20 degree and actual is 25 degree. So 25 will be taken to over here, 25 minus 20, you get a 5 degree error. So the aircon is going to be on until it gets 20 degree over here. 20 will get the information, and 20 minus 20 is 0. It's going to be 0. The error is 0, then the aircon will be off. So all the system trying to get as an error 0. Okay, that is a very simple generic. We have multiple gain or multiple feedback sensor will be there. Depends on the system. We have a gain 1, gain 2, gain 3. You can put G1, G2, G3, any numbers. Okay, so that is the block diagram overview. And we have rotation techniques. We have 8 rules. So it goes by the arithmetic way, like baud mass, bit mass kind of thing. So whenever you look on the block diagram given as a question, we need to see whether rule 1 can be applied. Rule 1 is nothing but there is to gain in a series form in the block diagram, and it can be combined. Okay, so it can be combined, two gains, and there is nothing in between. We can combine like this. Okay, it's kind of multiplication. When it's two blocks together, we can be multiply the products. And when two blocks, two gains in the parallel way with the summing point, then we can make it as an addition or subtraction accordingly. Okay. That is rule 1 and rule 2. So whenever you don't find anything on the block diagram as a rule 1, then you can see whether rule 2 is available to apply. When rule 2 is not there, then you can go for rule 3. Okay. Rule 3 is kind of a feedback loop. So it can be a negative or positive feedback. So that is the short form of it. We can able to use these formulas plus minus accordingly. When you say negative feedback, then we can say 1 plus GH. When you say negative positive feedback, 1 minus GH. So that's the difference on it. So that's the overall rule 1, 2, 3 when you say first choices, and it goes in the sequence of it. Okay, and that is where rule 1, 2, 3. Then we have a second choice, which is all have an equal preference. Rule 4, 5, 6, 7, 8. Okay, so rule 4 is adjusting the summing point. So that's what you can able to see on your block diagram, moving the summing point to another position. Okay, so rule 4. Then when you talk about rule 5 and 6, Okay, shifting the summing point before or after. Okay, so that is what rule 5 and 6. Shifting the takeoff point before and after. So it is like 5 and 6, 7 and 8 is almost similar. So if you look on that, whether you can multiply the gain or divide the gain. Okay, summing point we already know that is a round circle. So what we can see rule 5, that is your summation point. So moving the summing point before and after the gain block. Okay, so if I move the gain block before or after the summing point, then you can add accordingly a new block on it. Okay, so that is what rule 5 and 6. So if you say now the summing point is here, gain over here, but I want to move to this way, then the summing point move this way, then we can add a gain on it. Whereas over here the gain is before the block and I want to move it to the front, obviously it is going to be add like a 1 divided. So one is multiplication, one is division. Okay, so that's the only thing we can see from rule 5 and 6. Of course, we will look on the question, then applies the rule 5 and 6 where the summing point is moving. Okay, then again takeoff point also moving back or front. So takeoff point is like a point where you take the information, the gain block moving front or back. Okay, these two is almost similar where the summing point is there, where you want to move it. One can be a division, one can be a multiplication. Okay, so that is the formulas, and which you can able to refer the formula sheet. So that is what we see on the last session, and the overall things. Yes. Rule 4 is basically is adjusting the summing order. There's 2 summing point, it can be positioned anywhere. Okay, but maybe we'll look on the question, then examples, then we can able to see the things. Okay, that is the overall recap on last session. So we are more towards topic 2. We have a transfer function, block diagram, reduction techniques. Today we are going to cover higher order system, which is topic 2.4, and we are talking about control system response in topic 3. Okay, so that is our agenda on today. So we already completed until topic 2.3. So today we will be going to recap a little bit, and then we'll jump into 2.4 and topic 3. Okay, so any question at this moment before we continue? Okay, good. Okay, so let me take your formula sheet. We try to use the formula sheet to have more points on it. Let me, this is class 2, okay. So come to the first question about rule 4. Okay, so this is consider the rule 4. The summing point, either this is actually original. Okay, then I want to transform this into this, which is something like I'm moving the summing point B1, B2, I can reposition. Okay, so there is nothing to do on any of the parameter, need to add gain or anything, no need to do anything. Okay, so moving the summing point. I think let's go with the example, then we can able to see where this rule 4 is applied. It is one of the rare conditions, but sometimes it will be useful. Okay, maybe for a start, we will do from example 1. We have plenty of exercise. You can able to see this kind of question in your assignment. Midterm assignment will be available at least 2 questions like this. The question is something like this. So they ask, reduce this block diagram into a 1 block. Okay. So what we can see, that is your input, and over here extreme is your output. So first we need to see rule 1 can apply. Okay. Yes, rule 1 cannot be applied, but rule 2 can be applied, but how it's going to be joined based on the sign over the summing point. So the answer is D4 plus D3, D4, D5. Okay, add together like this. Okay, so that's how you are reducing and make it simplified block diagram. What is now rule 1? Over here. Okay. So rule 1 can be applied because there is no other things, no takeoff point, no summing point. So I can able to combine it. It's basically a multiplication. Okay. So that becomes G2 bracket of that all terms. Okay. Now rule 1 cannot. Rule 2 cannot. Rule 3 yes. So this portion. As a feedback unit, yes, this portion we have one gain, one feedback, and one summing point. So, is it positive feedback or negative feedback?
Negative.
Negative feedback. So, what is the answer is going to be? 1 over 1 by 1 plus or minus?
Plus.
1 plus. Okay, 1 plus GH. Okay. So 1 plus GH. Okay, not 1, G1. G1, 1 plus G plus H1. Okay, so that is simplified that entire block. Now, rule 1.
We have rule 3.
Rule 3.
Rule 1.
Rule 1. So, yes. So, rule 1, because there is nothing over here, yes, it's just a multiplication. So, whenever say multiplication, you can just use the numerator multiply. Okay. So, you can able to see the entire jargon over there. Okay. Now, rule 1. No, 2. 3. Okay. So, negative or positive? Negative. You can see the sign over to the summing point always, whether it's a minus or pluses. Okay, of course, the more bigger it to happen, this whole thing, as per the formula, classifies as a G. Okay, so then G, this is H1, right? As per the formula, this is called H2 over here. Okay, so that becomes like that. Of course, you can write a very detailed one, but you can first have to review first. Then next session, if any question, you can also come back. Of course, is that? Go back, yes. Okay, so how it works, basically we can say G1, right? So the entire thing is so-called G1. And maybe you forgot about this one first. Okay, so the top one we'll compare first. G1, G2, yes. G1, G2, bracket G3, G4, G5. Okay, so the entire thing on the numerator, yes, is there. Then we can say 1, right? 1 plus G1 H1. Okay, so it's basically this entire thing plus multiply with H2. So let forget about the denominator over here. There's a numerator over there. So G1, G2, H2, and all this thing. Okay. Then there's a denominator is there, right? So you need to. We have a denominator over here and here, right? So then you need to do a common factor, take it out, then cancel. Okay, that become you have a bigger blocks on it with the expression. Questions? Okay. Of course, this is rule 1. That's all. So when the question given, it will be end up like one block with the expression. That is we call as reduction of blocks. Okay, so I have so many blocks reduced into one block. Okay, so that is the example 1. Do you have any questions? Okay, basically either one only they will ask. Either you go by block reduction techniques, or end of the day what we are getting. So transfer function, output versus input. Either it can be go this way or go by the expression using D or S kind of thing. So we need to write this. They cannot combine both together. Okay, and block reduction techniques. Today, maybe we'll take the last time what we do the expression way and try to make as a block diagram today, and we will get the same transfer function. We can able to compare. Okay, so we'll go one of the question and we'll do it the same. Okay, so now the assignment will have a defined block diagram. They don't even start from like how to make a block diagram. They given the question as a block diagram like this. So they given the question like this. From there you can end up like one block. Okay. Yeah. So we'll see our existing question what we solved on the last session to make a block diagram. From there, how to reduce a block diagram. Okay. Guess. G1, G2. Yeah, okay. So G1, G2, rule 1, multiplication. Yes, now 1, 2, 3. If 1 cannot, then only go 2, then cannot, then go 3. 2. Yeah. You need to go by the orders. Okay, you cannot, even though yes, there is a 3 is there, we cannot do the 3. If 1 cannot, then go 2 first. Yes. 2 need to make it just addition. Now you cannot make rule 1 because there is a takeoff point over there, so in between the 2 gains, so we cannot do the rule 1. So we need to 3. Okay. We get the 3, then it is a negative feedback and try to get the block. Now 1. Yes. Good. And rule 3. Quite easy. Okay, so this is there will be 2 questions on your midterm assignment out of 5 questions. Okay, or maybe you can say like 1 question A and B kind of thing.
Okay.
Yeah, it's like we can say it that way. 4 questions overall. 3rd question will be this way. You can refer this slide and then do it. Use your formula sheet nearby. Then you can work out it. Okay, so I think we have more exercise. Explore and keep your formula sheet. That's why every question I try to repeat the formulas. Yes, where we can start. Rule 3. Okay. Yeah. G2. H1. Yes, correct. Okay. 1. Okay, because the overall all in one row, so you can combine as a multiplication. Okay. 2. Okay, so these 2. Okay, G5 and another block. Okay. 1. Okay. 2, 3. Okay, great. I think some question is very straightforward. After you cracking one by one, it automatically gets it. Okay, so I hope everyone is confident. Then we go a little bit tougher. Okay, next level, level 2 already. Okay, so 1, 2, 3. Okay, rule 3. G2, H2. Okay. Okay, that's where rule. Okay, 1 cannot, 2 cannot, 3. Oh, why? Okay, so that's where you can apply rule 4. So now this is takeoff point coming over here. Yes, it's good, but in between there is a summing point is there. So I need to swap the summing point. This is ideal example for rule 4. Okay, very rarely it happens. Rule 4 is going to be applied, but sometimes there is a break point on it. Even any of the rule you cannot apply. Only rule 4 only can do it. Okay, so now you can say interchange. Okay, so that's what you can say. Either, I mean, there's a negative feedback. Okay, you can add in also. Okay, that doesn't matter. So you have like summing point 1 and summing point 2. Okay, so I'm going to swap. So once I swap, so basically the thing will be the same thing. The connection from H1 still over there, which is over the 1 summing point, whereas the top one coming to the 2. So I'm going to be over there. Okay, just swap it. When you swap it, then it is much easier to work out. Rule 2. 3. Yeah. Okay, basically very simple to remember. When you get H, it cannot be rule 1 and 2. H is feedback, reverse way. Okay, so H is the thing we always remember, like our feedback in things. G is always forward. This is reverse. Okay, so sorry. Yeah, rule 3. Then 1. Okay. Okay. Now let's go on this. What is this? When there is a line, but no gain, no feedback, what do you call? I think we already talked about this. Unity feedback. I mean, one is there. If there's no one, there's no line is going. Okay, so it is one actually. Okay, then we can say, okay, there's another thing also. The feedback doesn't mean like always the takeoff point should be always coming, the line always to be coming at the bottom. So there's no such thing. Okay, so it can be on top. If you are get confused, you can redrop. Okay, and put it at the bottom. Now it is as a tradition what we are understood. Then it is a negative feedback and unity feedback. So over here, H value is 1. So G divided by 1 plus GH, right? So basically the H is 1. So G divided by 1 plus G. Okay, so we can able to substitute and get the answer. So are we good? Are we have any question? One more? Okay, so from here, next is okay.
1 plus C1, so we take it 1 as a common one.
Oh, this one. Let me see. If you want to really do it, you can just make it bracket also.
So we can do that.
Bracket enough. But if you really want to multiply, of course, need to multiply every term. Okay, then you can able to do it. So here, what they did is multiply every term.
So 1 is 1.
Okay, so now as per this multiplication, so I can say this is the simplest way. If you want to put it 1 plus G1 H1, 1 plus G2 H2. You can leave it like this, or you can go the other way, which is have a very big expression. How they do it? Multiply everything. Okay, so G1, G2. First, there's a 1. You need to multiply. Okay, 1 multiply 1 is 1. 1 multiply this whole term will get 1 G1 H1. Okay, then we have these terms going to multiply the other two terms. So this is going to be like G2 H2. Okay, then this term is going to be multiplied here, G1 H1 G2 H2. Okay, so either method is okay, it doesn't really make any difference. Okay, it's up to you whether you want to make it like this or you want to make it like this. So both is okay. Okay, whether you want to make it bigger or just make it as a simple one. Okay, so I leave it to individual. Whichever you are comfortable, you can go with this. Okay, I understood. I understand.
No, because time constraint.
Maybe the assignment you have a time. Maybe exam I understand it cannot be do too longer expressions. That's it.
The more we think, more we make mistakes.
Yeah, obviously it is. You can make it. Okay, so until now you get this from here. We are making something like this. Are we okay on that? Then any question on here? Like unity feedback. Then whole thing we need to rewrite. Okay, good. Rule example 5. Okay, where we can start? Rule 3, G1, H1. Okay, basically as I told, it doesn't need to be always like need to be drawn at the bottom. It can be anywhere as long as you look the arrow direction. Okay, then you can do it. Okay, let me see. It can be simplified the other way also. Splitting second summing point as said. Okay, let me see then why. Oh, basically yes, because if you apply rule 3, suppose there is one more summing point is there, we can split the summing point first. Okay, so the H2 that particular summing point, okay, this summing point I need to split so that H2 will be connected another summing point, then this H1 is connected over here. So first I try to split the summing point into two. So basically H1 is connected, H2 is connected, of course side by side, you cannot put anything in between. So that is the first step. Now you can start.
What's the rule?
Okay.
What was the rule?
Actually, it is a dividing summing point. It can be addition, subtraction. So it is, maybe you can say, part of rule 4. Yeah. Because rule 4 is not only swapping, splitting, even joining. I mean, joining is very rare, but splitting is possible. Okay, let me see where we are. Okay. Yes, we split first, and then only we can start the question. So that is your breaking point of every question. It's like where to start and how to start on it. And basically, of course, we can go 1, 2, 3, then accordingly the other 4, 5, 6, 7, 8. Okay, so here's rule 3. Rule 1. Rule 3. So over there, that particular portion, yes, it can be combined. Rule 1. Yes, going to be combined. 3. Okay. That's it. Okay. Quite straightforward. Sum is really easy to handle it, but the first breaking point is we need to think. After that, is everything goes very easy. Yes. Okay. So this where it comes out like. Can I apply 1, 2, 3? Look first. 1, 2, 3. Actually, if you look, all the gain is side by side, but there's a summing point, take off point here, take off point here, so I can combine. Okay. So 1, 2, 3 cannot be applied. So in that sense, I need to do some reorientation. I can go 4, 5, 6, 7, 8. Okay. Any order will do because all have an equal preference. Okay. So I just jump. Okay. So jump the summing point over the gain. Okay, so that's where now you can look at your formula sheet. So jumping the takeoff point, I mean not summing point, takeoff point. So when you're jumping before the gain, after the gain, so divide the particular gain, let's say G3 over here. Okay, so we can say over here just G5 over here. But the moment I jump, I need to add 1 divided by G3. So that is one of our rules. So when you move the takeoff point over the gain, then we need to divide the gain accordingly. Okay. Yeah. So now open question. Everything.
Move can be directly put G5 by
G5.
It should be after.
It can be here. Now we move from this to over here, so this jumping D3.
Yeah.
So that's why I add 1 divided by D3. So you're asking whether this side or that side.
Yeah.
It doesn't matter.
Anyway.
As long as this loop have that 1 divided by, even you can put it here also, okay. So no difference. It does still multiplication. Okay. That is rule 8. We are applying. Yes. Now 1. Now multiple locations you can say rule 1. Yes, you can able to combine. Rule 3. How about rule 2? Yeah. So you can able to add this one. Okay. Basically that kind of addition you can make it. Yes. 3. Yeah, this portion where I can able to combine 1, 3. Okay. Of course the detailed step is there, so it's okay. Okay, here when you come, it's not really required to simplify like a very expanded way. So you can write as it is. Okay, it's also okay. Because here the steps is trying to say how to simplify to make it. I don't want to get more complicated. Then as long as you do it, then it's fine. Okay, so that's example 6. Example 7. 1, 2, 3 cannot be applied. Okay, then it's your choice. You can apply, even some people say like 5 and 6, or I want to go 7 and 8. So it is moving a summing point before and after the game, or the takeoff point. So either one you can play on it because all have equal preference. Maybe just give a clue. Yes. So when I jump this to here, okay, what we know already, when you jump, divide that gain 1 divided by 0. So it's added. Okay, so then now rule 1, yes. Yeah, here rule 1, here also rule 1. Yes. 3. Okay, yeah. Feedback, we can make it. Rule 1. Rule 3. So it doesn't really need to be always come down the joint. So what is the main thing? Takeoff point and then summing point. Okay, as long as it goes and see, and you can very clearly see the arrow direction. So arrow direction, it is one is forward, one is reverse. So that is telling it is a feedback. Okay, so yes, we can combine rule 1, rule 3. Okay, good. Example 7, then example 8. 1, no 2, no 3. No. 3 can or not? Yeah, you can do something, but you all need to do first. Break the summing point. Okay. So even you can see another thing. So 3 summing point at one location. Try to break the summing point. You can be a multiple so that every point is connected to one summing point. Okay, I think I split it into 2. Okay, let me go back. Yeah. So split it into 2 summing points so that we can see the top G3 is connected to one of the summing point, and H1 is connected to the second summing point. So it's quite, I will break into 2, so it's much more easier. 3. Okay. Apply rule 3. Then again, what we can see, take off from here to this. That is, we can also shift it. Shift it means 1 divided by G2. Okay, need to add one more gain block on here. Yes, that become multiply, so you can able to do it. Now, rule 1, multiplication. Then we have 2. Okay. Then consider 1, right? So because here to here is joined, and they take up points from here to join. So that particular, there's no gain, consider 1 actually. So that becomes 1, so you can able to apply rule 2. Rule 1? Rule 3. Okay, so over here. Okay. Rule 1. Unity feedback, yes. Rule 3. That's all. Okay. There's always a small trick over on things. So if you cannot apply 1, 2, 3, then you need to see other things how to shift it. Actually. Even some approach different approach, still you will get the same answer because all have equal preference. Okay, great. It's getting complicated. That is a cracking point, I can say. Think about it. Too many. Okay, maybe start from here. Upper it is just a rule 2, addition only. Okay, so I mean the diagram complicated, but it is simple. Okay, sometimes it doesn't really need to be like a very straight line kind of thing. You can see a diagonal line still considers okay. Arrow direction is more important. Rule 3? Yes. So 2 rule 3 is there. Rule 1. That's very simple. Rule 3. Okay. So we are going to almost end here. You can split, you can think of this way. If you cannot apply 1, 2, 3, you can split the summing point, move the summing point, or take off point. This is feedback of forward. Forward. Because you see the arrow direction, it's always coming this side. Feedback means opposite side. So arrow is more important, direction will resemble. Unity, because 1, yes, now, complicated. You can split, okay, you can move the thing. Over here. Okay, it's kind of feedback. So we can able to, because once you go back, so what we can see, this particular line will be out, and that's what you can able to see, but the line is going to be joined over that location. If you're really confused, you can be split, okay? You can get one summing point like that, one takeoff point to this summing point. So you can split the line, then work on it actually. It doesn't really need to be skipped directly. Okay, so let's back. Okay, so that's all. So now it joined. We can see what is the other things we can able to make it. What? Okay. Jump. So at least it will be, these two gains can be combined. Okay, if I jump it. But when you jump it, obviously, sorry. When you jump it, obviously this is going to be divide. 1 divided by that. So that's why one of the gain point is there. So you can add to the same point. Okay, so now you can apply rule 1. Yes, now this. It can be a same summing point coming over here to the one reverse side. You can able to combine into 1. Then from there we can able to combine as a rule 1. Consider that is a rule 3, right? It is forward and this is reverse. Doesn't matter what is inside the block, so don't need to worry about the box actually. But we will see the arrow direction whether it can be suited for rule 3. Rule 1, multiplication. Okay, so that is overall 10 exercises is good enough. Okay, then I would like to elaborate the questions. It's not only for assignment, it can be for your final exam. Okay, this is some of the question that I extracted from the question paper. I put it for your reference. Later, I will going to share about like tutorial exercise. There is a 5 document which has have all kind of questions with the workouts actually. So that is hard copy. I mean like written one. That is the another thing I'm going to share on it. So this week, I mean next week we don't have a class, but we have a lot of materials. Okay, I will going to share more information. Okay, so spend on your time on next whole week. Okay, because the content here is like keep flowing, and it's just a matter of managing our time. Okay, so come back. That's one of the 11 exercises I listed over here. What you can see like mechanical translation. Okay, we have like a linear system. We have a spring, damper. We done our calculation on it. Something simple. Then linearly moving blocks. That's a typical thing. Question which is say like x1, x2, okay, m1, m2. Draw the block diagram between the relation as the input is here, output is x1. So it means like that my input I'm trying to pull, that is f is my input, and output is x1. How much x1 is moving out from the current state based on the applied force. Okay. by pulling the applied force, of course, this mass is going to move, spring also going to move, and this mass also going to move, which is resisted by the damper. Okay, so all is in one connected system. So the question is draw the block diagram. Okay, then reduce the block diagram. Okay, so that is two questions, A and B for exercise 3. Okay, so there is a rotational system. We didn't work out the rotational system. This is one of the typical questions, which is to say a torque. I'm going to rotate the shaft. Okay, when I rotate the shaft, there's a mass, damper. N is nothing but gear. Okay, spur gear or helical gear, you can assume. The schematic is something like a line like things that is called N1 means is already number of teeth on the gear. Okay, that's usually specify N1 and N2. Okay, so that is the gear, and the first gear connected to the second gear, which is able to transfer the motion, and we have a spring which is grounded or connected to the fixed position. So question, the schematics what we know already. And what is the question? Find the transfer function. Okay, so it's nothing but output versus input. Output, even if they given the question like theta divided by t means you know already all the numerator is output. Okay, so theta. So this is my output and my input is t, torque. Okay, so based on how much I'm twisting, based on all this component with the gears, it will be coming, how much angle it will be turned to the second shaft. Shaft 1, shaft 2. Okay, so the question, say you need to calculate what is the transfer function and to understand what is the time constant as well as gain constant, then natural frequency and damping ratio. Okay, so we are going to see about this. It's just a mere formula to substitute to get the value of it. But you need to get it your transfer function, then only can do it. Okay, this is about the fluid system. We already worked out this question on the last session. And here another question which is like a control wall, hydraulic positioning systems. And the electrical systems, we already did similar, but it is have an inductor on here. This also we did. Okay, that's a typical question. Answer is here. Why not? We can do it now. Okay, so this is consider one of the assignment in part 3A question. One of the questions A and B. Maybe we'll work out two questions. Do it now. You can refer your friends. You can discuss, Google it, but do it. Or you can ask me, but do it. Answer is this one. Okay. Of course, usually the gear. Okay, basically, rule 1 cannot. Rule 2 cannot. Okay. Rule 3. Without this takeoff point, then maybe rule 3 can apply. Okay. So rule 3 cannot apply. So rule 4, 5, 6, 7, 8. So what is the suggestion? Maybe I'll ask first. Shift. Yes, correct. Shifting. Which one? Move the point above the gate. So over somewhere here. Okay. So by doing that, jumping the gain, what do you need to add over here? 1 divided by G.
So can I jump inside?
It can be. But better do it this way because summing point we don't have rules on. So always in jumping either gain or the summing point or takeoff point jumping the gain or summing point jumping the gain, but not between these two. Okay, so we don't have rules like that. Probably we can do a research on it. So probably you can have a rule 9. We can make it. Okay. It's possible because as long as you do a mathematical expression, then finally, as long as proven, okay. Okay. Yes, great. Maybe I'll suggest you can move this over here, and you can add one more block over here, 1 divided by g. Okay. Okay. For this, every time you need to redraw, keep redrawing. Then only we can complete this one. So this question usually kind of lot of blocks on your pages. Then only you can be simplified. Okay, work out. Let me.
Actually, it's okay already, but he's lazy to come.
My person wait.
Around 1 hour.
Okay, so once you do that one, then we can apply rule 3, right? Oh, okay. Once you, yeah, you can say rule 1, you can combine. Then you can apply rule 3 over here. And see how it is. Okay, maybe I just write down based on your feedback. Let me put it this way. Okay. Okay. So by jumping, we'll have this one. This one you combine into one block. Very good.
1 plus H2.
Right? For H2. Okay. Then on top we already have H divided by G, right? And consider this is 1, right? So basically this is 1, and the top one multiplication, you will get something like this, G or H1, okay? H1 divided by G. So what is this?
Now we can
Rule 2. Okay, plus or minus? That's a good question. This is plus. Okay. And here, minus. The thing is, the line coming in, here is minus, here is plus. So we need to see accordingly. Yes, this. So this is a rule 2, right? This is addition subtraction. Okay. So 1 minus H1 divided by G. That's all. So rule 1, multiplication. Right? So, but if you want to make it this common factor easier, if I can say G minus H1 divided by G. Can I write this way? So it's a common factor. Maybe I'll write overview here. G minus H1 divided by
So
G.
they also have positive means negative.
Oh, sorry, maybe then opposite. So should be okay. Maybe better right here. H1 G minus 1. Okay, so this term is positive and this term is negative, so we can do it. Then when I come here, H1 minus G divided by G. So maybe I will refill H1 minus d divided by d. Because the multiplication you can directly stack up. Okay, so we can say h1 minus d divided by, yeah, this is cancelled, 1 plus dh. You can end up like here. Yeah, then further you cannot reduce. What answer?
Yeah, same.
Oh, we already got to the answer. Okay. So, question from any of the step. Of course, every time when you do it, you need to redraw every time to avoid confusion. Questions? We good? Yeah, take note. I think I need to get a eraser from next session, next class. Okay, so manually reduce the block diagram to find the transfer function, which is nothing but what we can say this is your transfer function. So we can say transfer function is nothing but output versus input. We can say h1 minus g 1 plus g h2. Okay? Any questions? Any of the steps? The black color is just for your reference, side works, but actually you can see all the blocks, all the steps to be carried. So that's your step 1, step 2, step 3, step 4. Okay, so we'll go that. 1, 2, 3, 4. Okay, so every time you need to redraw your block diagrams. Questions?
Sir, can you explain the minus one again?
Oh, okay. This portion. Okay, basically now here to here, okay?
Yeah.
So, okay, maybe I'll put it this way, easier. If I say plus, okay, that is your sign of this thing, right? Okay, so I put it, first this one is a sign of over here. Okay, so maybe I just write positive, right? So maybe I can say positive h1 divided by d. Okay, then this is going to be positive, I can say plus 1. Okay, but here our case is happened like minus, so I try to make it as minus. Okay, but of course rearranging this, you know, right, common factor, just make a common factor, then you can do it. Okay, this is minus. Yeah, it's okay to have a question because now, okay, one of the question is simple, always like this. The other one is like a very big block. Okay, so that is always part B. Yes, questions? Yeah, always like a interesting things. Let me see. It doesn't need to be always GH, it can be yes also. Okay? Or maybe I can leave it now. Let me see. What time? 7:30. We started like 6 or 6:30. Okay, maybe I'll leave it this one. You can do it. The answer is over here. Okay? Maybe first a simple thing. Rule 1, 2, 3. Okay, yeah. Rule 1. Okay, combine. So when you combine, what will get it? S square. S square. Then rule 2. Okay, maybe tell me the rule
Yes.
2
Answer is yes.
answer.
Yes.
S square.
Yes.
Right, rule 2, right? Yeah, okay.
Two plus
Yeah, what it is. Because okay, one is plus, one is minus.
S cube
S cube. Okay, S square
times 1 over S
minus 1 over
1 over S.
S.
So is S cube.
Cannot be. Oh, you want to make a common factor. Okay, okay. So that's the first step. Of course, this is S square plus, okay, that we put it. Then this gain is forward. You look the arrow. It's not like a feedback, so it is forwarding, and you need to see the minus sign. I mean whatever sign. So we take minus. Yes, we substitute minus and the gain whatever it is. If you take a common factor, yes, S cube minus 1. Okay, that become one big block already. Okay, so next, think about it. What are you doing? Okay, now I think we will explore. But anyway, this slide I'm going to share. Okay, by the way, everyone can access the Google Drive, right?
Yeah.
I think I share until class 3, I think. You can check it out. I did have a hint on it, how to proceed. Okay, so next thing, the block diagram is like this only. Okay, very simple. But once you get the value on it, then you can substitute the answer. Okay, I think this is already steps, is already there. Or basically they given a relation. Okay, G1 means D plus 2. So G2 means 4, H1, H2 is D actually. Substitute all the things, then it can be expanded till here. Then you can able to find what is the gain constant, time constant. But it works from this way. Any clue how to move the first step? Step 1, I mean like rule 1. Yeah, rule 2. No, rule 3. Can be. You can move. We are moving takeoff point. We never seen the summing point moving. But summing point moving, your formula sheet you can refer is the rule 6, 7. I mean 7 and 8. Okay, 5, 6 is always takeoff points. So it is like a same equal preference. So you either move multiplication and division only difference. That respective gains or division. Okay, so I will leave it. So you guys work out, and if you have any question, please post the message on it. So that is the overall the reduction of block techniques. We can work out, then we'll see. Okay, so next. Okay, 2.4. Okay. Okay, so work out the exercise so that it can be explored. Maybe we start with the class exercise, you do it, then you are comfortable, then move on to the exercise. Okay. So over here, we are in the next phase, which is higher order. Higher order, it is something like, initially we saw those 2 components or 3 components. Okay, now even we were moving towards more components. That's because higher order. So we can say first order, which is nothing but a simple in and out, single input, single output. We say like there is a water coming in and water going out. So that's the only thing over here. And that's why you can say single input. There's a water pipeline in, one pipeline. They're called single input. Single output, one is outlet over there. So that can be a multiple input, multiple output, like more things will be there. Alright. Okay, so this is we already done and we calculated the thing which is first order. How do you know it is a first order or second order? Where is the transfer function? Okay, here. Transfer function is nothing but output divided by input, and we have the formulas what we get it. How do you say it's a single order, first order, second order, or higher order? I think I did specify on the section 1 or section 2.
Square.
Yes. So D. So basically the D what is the power of 1 is first order. When you say 2 means is second order, D3, D4 it can be considered higher order. Okay, so maybe the thing is I can say now this is a way to do it. Like we have formulas, I mean the equations. Okay. There's an equation, you need to write 1, 2, 3, then rearranging the equation until you get it like your transfer function, until you get your time constant and gain constant. Okay, so that is rearranging until you transfer function, gain constant, time constant. That's it, the question finished. If you are using expression way, but when you talk about like block diagram method, because one of the questions say like given everything, do it block diagram method, not by expression method. This is expression method, also called differential equation method or Laplace method. Okay, but I can say it can be a block diagram method. How to do a block diagram on it? Okay, let me see. I need to get a cleaner. Don't have on this session. Okay, so maybe I'll go and get it. In that case, work on the other question. Let me prepare for it. That's where we stop, right? This one done. Okay, maybe we do this one. At least we started this one. It is somewhere here. Okay, so this center portion we already block reduced. So continue to see whether this answer we're getting and try to get the thing.
Let's say you get asking me whether no, but it's error correct. I don't know what you think. My number like
So how much you are venturing it? Maybe you can guide me. Coming point. Consider here, right? What is the SQ?
S cube -1.
Minus 1?
S.
Yes. Okay.
Then
One summing point.
the one that
Because
we had compared it.
This one. this
summing
one we
point,
combine.
right?
Okay,
Yeah.
okay. Then what is you have? One more game.
One more.
This one feedback.
And feedback.
Feedback on top.
Feedback on top.
Yeah.
Oh, yes.
Yeah.
And below also after
Here also.
one more.
Okay.
Yes.
Good. So any improvement from here?
Maybe,
Yes. S cube. How do you get it? Okay, so that is where we are here. Okay, this is S square, right? Okay, so S square and this is 1 divided by S. So apply rule 2. Rule 2 is because just addition, parallel box. Okay, so S square on the top gain minus 1 by S. Minus because it is saying minus. Okay, so otherwise it's going to be plus. Okay, S square minus S, 1 divided by S, that is your first step. Okay, then now you are taking a common factor. Okay, so make it as a common factor. S square multiplied S become S cube and minus 1. Okay, so that is become your block coordinate. That is applying rule 2. Okay, so just return over here. Yeah, so from there till one more block is here, one more block here. There's 2 blocks is there. Okay, so what is the suggestion?
3.
3.
Yeah. S3 minus 1 divided by S. Yeah.
2?
Feedback.
Oh, on top.
Yeah.
Oh, okay, okay. So this part. So if this part, obviously this is
1.
1. Okay, so unity feedback, you can play based on the arrow direction only. So arrow direction going this way means it is a feedback. You can put 1 if you don't have anything. So this things, okay, very simple. What is the G divided by 1 plus GH?
H.
Okay, H is 1 based on this. G is S cube minus 1 divided by
S.
yes. Okay, once you substitute, what do you get?
We can simplify.
You already simplified. Okay. So let me put it here. Easier. D is nothing but S cube minus 1 divided by S. Okay, so these things, maybe still summing point is there. I'll get one big block and I get one more block. And that's one more takeoff point over here. So what is this? Gray box. So I can substitute S cube minus
S cube
1
minus 1.
divided by S 1 plus S cube minus 1 divided by S. The thing is going to be 1. Okay? So it's going to be S over here. Then you can cancel. So S is going to be things S plus S cube minus 1. Yes. So are we good? Or maybe too complicated? So basically now what you can see, from here I'm using the formula. Okay, so that is with the gain feedback. H is 1, G is nothing but the entire block. So we are using the formulas to substitute. The G is this and 1 plus G again, then this, then H1. Okay, so we are going to substitute all the values of the G and H. Then if you take a common factor, it will be like this because the numerator remains as it is. Whereas the denominator, we need a common factor. So s, the s cube minus 1 divided by s. So now we can cancel. Okay, so we'll end up like this. So maybe I'll rewrite because it's too low. Okay, so that is the overall block. I simplify rewritten, and maybe I'll redraw this one. S cube minus 1 s plus s cube plus minus 1 divided by 1 by s. Okay, one more gain. Okay. Did I delete this one? Okay, so this kind of. So yeah, okay. So this is rule 1. You can multiply directly.
它增值，对我讲一种它值，对，它说放进去，这个是整个放进去，这个是这个我们现在用来个，就是说那个资料后面有啥秘密，其实
So yeah, s cube minus 1 divided by s plus s cube minus 1.
天天看，昨天那真难。
You can multiply. So you guys will multiply. Oh, this is the feedback also. It's going to be complicated. Yes, we can do it. So I can write this easier.
有一个人骑，有人骑，我才骑了，我谢谢你说我才骑。
Okay, so it's just a multiplication of the two gains. What you can say, s cube minus 1. S, you need to multiply the entire denominator. So you get like square 4. Yes. So we good? Just multiplication. Okay, so we good? So I take one block, second block, multiply, we'll get it like this. So I'm going to substitute to this block. Then the last step, of course, you can rewrite. Then you can able to complete the circuit. So it's s cube minus 1 s square. Maybe you can rewrite because higher power better to the front. So you can say s power 4 s power square minus s. Okay, you can be put any order. So usually higher numbers you can put it at the plus. Usually summing point you also put this way, so that it is like a summation point. So here nothing but 1. Oh, this is always I'm missing. What here? Also a missing. Okay. Always missing. We never combine.
都话说，什么？是看跟我们的
Good. Thanks for reminding. That's the usual common mistakes that happen. When you keep looking at stuff, you can make mistake. Okay. So rule 3. Okay. So plus or minus.
Minus.
Okay. So that is another one important thing. When you do it, take note the sign. Because the sign change, of course, the answer is going to be different. Okay. So what is the formula? G divided by 1 plus GH. So that is here H. Okay, so you just multiply. So G minus 1, then 1 plus entire term. It's going to be cancelled. Maybe I write down first so that people won't get confused. Kind of division, because this entire term is g, so I put it s cube minus 1 division of the denominator values. Again, over here s cube, better rewrite, even though it's going to be bigger, make it better. So s cube minus 1 divided by s power 4 plus s square minus s 1 plus g is, sorry, s h is like this. Then we have s cube minus 1 s power 4 plus s square minus s. Okay, so you multiply, you can able to get it and you make it as a common factor. Okay, so I can put it this way, s cube minus 1 then this entire term will be the other side. We have s power 4 plus s square minus s plus s power 4 minus s. This
没
thing.
啦，我说不好你找到宝贝，
Okay, so basically I take a common factor, then we can able
这
to
不是吗？
strike
我
off,
说你自己懂宝宝。
then you can add in to the final one. Yeah, okay, maybe I can rewrite, I think you get the same answer over there, s cube
不同是不用懂宝贝，不同是不用懂宝
2
贝，
s power 4
不同是没有懂宝贝，
like that.
很少懂宝贝。
Yes.
2 yes.
Oh, here one more.
没用的就这样对吗？
Okay, so you will get the same answer which is the last step. You don't need to look on here, you can look on this, is the answer as the last step. Okay. Of course, a sort of board, you can write even nicely, very clearly. You can go simple rearranging and rewriting. Question? Any of the steps? Is it visible? Let me see. Okay. So it's common factor rearranging, then we can able to make your final answer. Okay, so there's a definite answer, definite question from this on your assignment. Next week. So next week you are going to handle this question. So are we good? Or we have any question or any of the steps?
And 6 the h.
So this one I can leave it. Let me this one. Okay, so are we done? Okay, once you're done, let me know. And who are done, just recall what we did on our last session based on the tank. Okay, so which is based on the tank, which is inlet, which is Q in, Q out, and the head. Based on that, we try to develop 3 equations, then rearranging the equation to find what is the transfer function. But if the question never state, you can go anyway. But if the question say solve using equation and block diagram method, 2 methods they asking to solve it, the same transfer function. So the first method, equation method, of course we know we return 3 equations and then rearranging the equation until to get what is your transfer function, output versus input, time constant and gain constant. This is the equation method to solve it. Okay. Then they ask sub question, block diagram method. Okay. How to make a block diagram? Okay, so that's what we are going to explore today. Because now we know once you make the block diagram, how to reduce the block diagram. So how to really make the block diagram of it. Because from the question, how to make block diagram. Okay. So are we good? Or we have any question on here first before move on? Pencil. Why? Any particular things? Oh, okay. Probably no. But you know there's a pen which have a eraser.
Actually, the one using exam that we use.
Yeah. If anything problem, when you draw right, strike, then redraw it at the next step. Always draw. Don't worry about like very closely draw it. Try to give more space. Ask more sheet. Give me more sheet. Okay, don't worry about the papers over on the exam. And make like a 2 or 3 blocks only on one page. Don't squeeze yourself actually because I'm the one going to read. I will try actually then. Then what you written? Oh my god, I need to apply light and everything. Use the camera to zoom and read actually. Okay, don't worry about paper. Get more paper on the exam. Okay, so that's the difference on the COVID and before and after the COVID. COVID all online, so it's much more easier. But still, the thing is, still need to write. You are scanning, and that's why I say when you write unruled paper. Don't write on the ruled paper. It's sometimes the lines collide each other, and you write smaller. The spiral or cube, I think whether it's spiral or 4 actually, they are able to read out it. Oh, see. Oh, okay. You want to take? I don't know whether we covered fully. Let me see. Yeah. We did, and maybe take the photo here. I think we started here. That's the SQ things. Okay, that's the first time. By equation method, we solve from the equations. I mean, any question how to make the equation? Because there's the 3 equation we found based on this. Okay, that's the first thing we did. Which is nothing but your Q. How much head is based on your inlet and outlet. So that's your first equation. Q input minus Q output. Okay. What is Q? Which is based on the area of the tank and head of the tank. And the next output of the output flow rate is based on the head output and the radius or resistance. So that's the 3 equations. So how to make the block diagram? It's very simple. Prepare everything. Then we can start to work on. Okay, first thing. As we know, it is output and input, right? Where is the output? Where is the input? Left side or right side? Yeah. So input, output. So whatever you draw, feedback, gain, everything between input and output. Okay. So that's how we always start the block diagram. Okay. So what is your input over here? That's your input, right? QI. QI is the water coming into the tank. That is the input. What is the output? QO. Okay. So what is your input? QI. Okay. What is the output? QO. Okay. So that's how the block diagram usually need to be started. Better I write down the description suppose for your reference. I think I better delete. So this is the block diagram. You need to write first the expressions, then this is just for your reference only. Input, output. Okay. So first, for block diagram method, still the same thing. First, you need to refer all these 3 equations. You still need to write. Okay. From there, we need to do it. Let me write so because it's easier to track it. Otherwise, we will be miss out. Okay, so what is our equation 1? Q is nothing but and AD H0 and Q0 H1 divided by R. We try to use this into over here. We can start from input to output, okay? And we try to connect. Is there any equation related to 0 and I from equation 1, 2, 3? Yes. So if you look on that, input minus output is nothing but Q. How to make summation on your block diagram? So you need to make a picture this. Okay, that is your summing point. So summing point, I can make it. So I need to get the Q0, right? So this is what we can say. I'm taking out the value of Q0 and the entire line carrying Q0, okay, until to the summing point. So what we'll get? Q input minus Q output is nothing but Q, as per your equation 1. Can I say this way? And this is going to be minus, right? I need to put minus. So very simple to narrate. We can say from here there is a signal coming, which is Qi. And here I'm getting one signal which is minus based on the sign I assigned. And what you are getting is Q0, which is nothing but Q, which is over. After adding this, I will get something over here. It's nothing but Q. Are we clear on this step? So I'm trying to get equation 1 and I'm making the lines accordingly. So are we clear on this point? We need to fulfill all the equations into a block. And you can make any connecting lines, any blocks or summing point as you wish. You can do it, okay? But to fulfill the equation. So based on this step, my equation 1 done. Okay, so basically every step when you do it, okay, I'm focusing on this, I take it. So I already put this equation into my block. Okay. Are we good? Or we have any question at this moment? So because the previous one, what we did using equation method, expression writing until to get your transfer function, but now we are going to use block diagram method. Okay. And later you are going to reduce the block diagram. Okay, you are going to do that to get the same transfer function. Okay, good. Okay. Then what is the next thing we can able to make it? We have equation 2 and 3. 2. Okay. So as long as Q is there, anything relevant to Q, then we can able to use it. Okay. And what is the common thing between 2 and 3? H0. See, it's the same thing, right? So over equation 2 also we have H0 and things over here. But now you locate this Q and Q0. Where is it on your diagram? There's a Q, there's Q0. Okay, so it's already there. So in between, I can make H0. Okay, so because there is a relation between these two, in between is H0. I don't know what is the block will be going to come in, but roughly we can draw this step by step. Okay, so I return H0, then we can proceed from here. So what is the relation between Q and H0? So equation 2. Okay, so maybe I'll write Q equal to AD H0. Okay, so here what you get Q and here will get H0. So in another term I can pull this way. Can I write this way? Just make this entire term going down. Okay, so end up like QAD equal to H0. Okay, so I can make a block. When you multiply this and this, okay, basically you need to get H0. So what we have, now you can compare this. Okay, so Q multiply on this block, that is equivalent to H0. Okay, so 1 over AD. Because this is Q already there, so I can say 1 over AD. When you multiply, you can do it. Okay, maybe I'll just write first. Sometimes when you write, you are not clear, very simple. So once you write, this is just a multiplication. Okay, so you can see Q divided by AD. Right? When the signal coming as a Q multiply with AD, that is your result. That is nothing but H0. Okay? Yes. Now it is very clear what I am getting is H0. This is for your reference. Okay, what I am returning over there is a reference, and that's how a gain block you are adding over here by fulfilling equation 2. So equation 2 I am completing. Okay, go step by step, then add in accordingly. Okay, questions from equation 2, one block added. So now the last step is here H0 and Q0. Equation 3. What I can add in a block? I need to add a block. That when I multiply with the block, I will get Q0. Okay, maybe can I tell it here? Or I want to take note this portion. I want to take a photo. Yes, this is equation 2. First I return the equation 1, now is equation 2. So basically we try to rearrange the equation 3. H0 multiply with this to get, it is already in the form. What is that? 1 divided by 1 divided by R. So we try to rearrange and we can able to make it. So equation 3 is simple. What we can see, H0 divided by R. Okay, so it's already there. The final output is Q0 and H0 we are coming in. So rest of the remaining terms we can write is 1 divided by R. It's very simple, just multiply this, you will get it over here. H0 divided by R. So that is equal nothing but Q0. That's how we can do a simple one, then we get your block diagram. So any question? Now equation 3 also completed. So that's how your expressions first you write, and then you try to make a tick and try to make it inside your block diagram. Once you make it into the block diagram, that's it. Okay, who are done? Where do you see? Maybe I'll try to rewrite because there is some extra for reference, but I will draw it nicely. Qi summation, and we have one gain 1 by AD, and one more gain, 1 by R, and Q0, and you'll get it over here. Yeah, so what we can say even Q0, because it is the value is coming. Okay, work out and see whether you can be able to compete. See whether you get the same transfer function. So I just redraw for your reference. This one is
1 by 8.
rule 1. Yeah, go ahead with the rule 1. Then you can ADR. Okay, ADR will get it. Okay, so use the rule 1 first, then you can work out. So that's your block diagram. So what is your G? 1 divided by ADR. Yeah. And your unity feedback H is equal to 1. You can write very detailedly, then you can see. Okay. Let me delete first. Okay, first you take note this one. Who will not take note, first take note, then we'll start on it. So how is it? Because it's a reciprocal, so you need to, yeah, upside down. End of the day, the answer you must get something like that. So everyone written this. So I will start from here. Okay, so basically the first summing point. We don't need to keep on. Okay. Yeah. So 1 over ADR. Okay, using rule 1. Okay. Then that's why you get right. Just a rule 1. Then we can say it is a unity feedback. Then it is minus. Okay, so when you have minus, the formula is G divided by 1 plus GH. Whereas for this case, H equal to 1. So what you get is G divided by 1 plus G. Okay. So now what is the G? Of course, G is also there. 1 over ADR. Okay. So that is your G on it. So let's substitute G divided by 1 plus G. So that's your formula. So 1 over ADR divided by 1 over ADR. Okay? Because I'm just substituting G equal to 1 over ADR. Because that is what you can see our gain. So there's common factor I need to take. So this one I remain as it is. You better write different color. We continuously write, then you get confused. Okay, so over here, first step, second step, 1 over ADR, and that's a common factor between these two. Okay, so I need to take this ADR 1 divided by ADR. So that's your next step, and these two can cancel. Okay, so cancel. So that way you can get it like, yeah, right there to use it. So third step, 1 divided by 1 plus ADR. So that is your transfer function. So which is supposed to equal to your equation method. Yes, correct. That's the equation method you rewrite until to the point you get like your transfer function using expression method, and this is block diagram method. So block diagram, we are using block diagram formulas, substitute, rearranging, and you will get it your transfer function in the third step. So what is your stand constant? Sorry, gain constant.
G over 1 plus G 可以是在哪里？
Okay.
我刚刚写
Formula.
1, what you can see here. And of course, we make sure this term is 1.
G over 1 plus
Time
G.
constant, not
Yeah,
AD, you can leave it.
Oh, yeah.
Yeah, maybe I can rewrite to avoid
那
confusion.
个 one ADR
ARD.
over 1 plus 1 ADR 呢？也是不可能的，
So is there?
那个
Yeah.
蓝色的那个。
有不一的 formula，所以我 H is 1，所以我 G is 1 over
Okay, so no matter whether equation method or block diagram method, you will get the same transfer function, same time constant as well as gain constant. So you need to see the question which method they are asked for, whether it's the equation method or block diagram method.
可以得个橙色。
But both method is acceptable,
上面
both
这个
method will get the
AD
same
跟 R
result.
了。
Okay? If
Like
the
the
question
first one,
never
just
specify, it's your choice.
这个
So which method you are prefer?
3
Okay.
1 over
Yeah, why not that?
Don't care.
Maybe just now you said like everything, oh, rule 1, 2, 3, then come back to here actually. Okay, so keep your word because now we are in the first order system. Okay, we are going to higher order system. Okay, so that is the real one. We are preparing ourselves, warming up. Okay, we are warmed up, I think. No, not warmed up. Okay, need to go for a break actually. Then you cannot really warm up actually. Okay, question first from here. Are we good? Or you have any question on any steps? We have step 1, 2, 3 over there to end up our transfer function, our gain constant and time constant. Okay, this is all first order because you see that B is 1, so it's first order system. First order system is very simple, less components,
G
end up
equal
with
1
first
over
order system.
ADR。
Like now we are going to explore higher order
G
system. It means like more
G
components,
meaning
but still the same way to do it, and the expression is getting bigger. That's it. No big difference on it. Okay. So I would like to write a higher order system equation because as I told, when you say 25 marks on any question, writing that equation itself, you get 50% of the mark. Okay. So it is relatively easy. Just read the formula sheet, then write out. Okay. So are we ready? Are we good? Okay. So everyone copy. Any questions for here? Okay. Maybe just copy it. And I would like to start from here. Here we go. I want to write equation. Okay. You can refer your formula sheet. For every component, okay, basically we have a component like T1, J1. We have damper, spring, gears, damper, spring. Mechanical rotational system, refer your formula sheet 2, page 2. You can refer the page 1 or page 2. Maybe look on the formula sheet. First I would like, okay, look on this. Find out all the system equations. Just the first question is here saying that just writing the equation, that is your first step.
哇，那前面是这个。
Then draw a block diagram, then reduce the block diagram, then find the time constant and gain constant. That is the overall question. Okay, no matter whether the system is linear, translation, or it can be a hydraulic or electrical, all have the similar things. This is a typical questions how it went be. Okay. Can be 3 or it can be 4, depends on the question. But end of the day, people will ask what is the time constant, what is the gain constant. Okay, are we good? Let's start on it. Look on the formula sheet to write the equation. Start to work. Who are copying it, still copy it, but who are done, please start. Is there any 8 o'clock already?
Yeah, 8:30.
Time running very fast. Okay. Okay, maybe we'll stop over here. 15 minutes? Okay.